Hello, everyone. Welcome to this session. Today, I'm going to talk about how you can deploy Spinnaker using Helm charts. There's a lot of ways you can deploy Spinnaker, and for production deployment, it is recommended you deploy Spinnaker in a Kubernetes environment. And there are operators available. Some people just install Helm and then go through the process of installing all the Spinnaker components. But I'll show you how you can use Helm to very quickly install Spinnaker. Like you can get a basic Spinnaker up and running in less than 10 minutes, and then we'll go through some of the customizations that you can do with Spinnaker. I'm Nirmalya Sen. I represent a company called OpsMX. I've been in the industry for quite a while, 25 plus years, and quite interested in the cloud adoption growth and how deployment to cloud environments can be made more seamless, smooth, and at a faster velocity. Before I go into the session, let me spend 30 minutes to talk a little bit about OpsMX, who we are. We are an experienced team that have worked in the past in companies like Netflix, Cisco, Oracle, AWS. We have 90 plus employees worldwide. And we provide services like 24/7 support of Spinnaker, manage Spinnaker, and then onboarding and design services around Spinnaker. We are very active in the community in Spinnaker, Kubernetes, Jenkins. We have active contributions, committers, and we love the open source community. With that, let's get on the agenda. What we're going to talk about today. Again, not too much of slides. This is a live workshop, so I'll really do a show and tell mainly, not slides. So we will walk through, like I mentioned earlier, how to do a default installation of Spinnaker using Helm very quickly. And then, look at all the customizations that are provided within the framework so that you can do a lot of the customizations that are needed for a production deployment of Spinnaker, including updating service and profile settings, updating images that are used, using custom images, how you can scale it up, custom size your images. So basically, and high value, basically all the HAL commands that you typically use to manage the component sizing and high availability of the components. You can manage them through Spinnaker or through the Helm chart. So I will show how you can do it. And then, any additional HAL configurations that you want to do that you can do from here. So I'll show you some of those things. And again, I'll walk through a few other configuration items that are there, like storage and all that. Working along, if you want to work along with me, if you have a Kubernetes cluster readily available, I think you can try that as I walk through it. A requirement that is there is that, it's good to have a persistent volume available because, I'm assuming all of you guys are familiar with the Spinnaker architecture. I'm not covering that at all here. It uses some storage, right, to store the pipelines, runtime data, and all that. So it uses a Redis and a Minio, and both out of the box, and those require storage. And this Helm chart by default uses persistent volume to store this. To access it, it's nice to also have a load balancer available. If not, like I'll show it to you, also how you can just access it locally. But if you want to make it available for others to see, it's good that you have a load balancer available in your Kubernetes cluster. Now, if you use any of the publicly available Kubernetes clusters, like EKS, GKE, or Azure AKS, they do provide support for these out of the box. And today I'm going to use actually a Kubernetes cluster in Google Cloud GKE to show and tell. Now, whatever code I'm going to use or samples of it are available in this Git repo. And a little while ago, I posted that link also in the chat. So, if you want to follow along, you can just click on that link and it will take you there. With that, let's go to this GitHub link. So, if you go to Spinnaker Summit 2020, there is the Spinnaker. There are other stuff in there you can look at also in there, which I used for some of my other sessions. But today I'm going to concentrate on the section where the content is in the Spinnaker directory. Before going in there are a couple of things happening with Helm, especially repos, publicly available repos. There was the stable repo. If you guys have been following or know about it, that repo, they're sort of not supporting, and they're basically making it a distributed, owner-owned public repos, right? So I checked yesterday. This is still available, where you can use the stable repo that's hosted in Google Cloud, and so you can use that. I believe November 13th, they have been saying this will be, discontinued and not available anymore. And in fact, what we did is we took whatever was available in the public repo and have replicated it in the official way to manage these repos going forward. And we plan to work with the community to get this within the community realm. This really should be owned and hosted by the Spinnaker community. But till that happens and you want to play around, you can use this to get it. And I'll be using this one today to run through it. Again, this is exactly same replica of what's available as part of the stable Spinnaker. Let's go ahead and kick this off like I'm showing it to you here. And what we'll do is that if you don't have persistent volume and or a load balancer, mainly the persistent volume, I'll show you how you can turn it off and work without a persistent volume. But let's first go ahead and run through this, okay? So if I go ahead here and look at Helm repo list, you can see that I have added this repo already here. So if you do this, run this command, Helm repo add, give it a name. I gave the name Spinnaker, and this URL, it's basically added as a repo available to Helm right over here, right? Now to install it with all the defaults, nothing else, just take the defaults and install it for me. I'm going to basically run this command, Helm install, give it a namespace I want to install it to, give it a name, and say install the chart Spinnaker in the repo Spinnaker. A lot of Spinnaker word in here, right? But just wanted to point out, maybe I'll go and update this so that it's clear what each parameter are. So this is the namespace in which to deploy. This is the name of your Helm install. This is the repo that you added. And this is the name of the chart within the repo, right? That's what we're going to install. Let's copy this in here. Oops. Okay, there you go. And let's look at our namespace, kubectl get pods -n Spinnaker. And you don't see any Spinnaker running in there. There's some remnants from my past installs and trying things out before this session to make sure everything is working and all that. So what I just did, I just kicked it off, right? It's Helm install in the namespace, Spinnaker, right? Like I said, it should take less than 10 minutes and we should have a running and a working Spinnaker available. With that, let's go look at a few things while this is running. Like I said, if you don't have storage or if you don't have a load balancer, mainly the storage, what can you do? I have lost my cursor and here I got it back. So this is a local copy of that Git repo that you just saw. And this is that Spinnaker directory, and this is the values.yaml. If you look at it, it is going to install a Spinnaker version 122.2, okay? And it's going to pull in the images, Halyard image from the public open source location where the Halyard image is available, and it's going to use the version 132. I'm sure all of you guys already know, if I go to Spinnaker Xpi versions, it will tell you, what are the versions that's available that you can use, okay? These are the current stable versions. And also if I say Halyard versions, I can go ahead and here and I can look at the versions available. So, 13 days ago, they released 140, but I'm using 138.0, a couple of versions older. Now, if you don't have persistent volume, right? And you want to try it out, like you're using, say, local Minio on your local laptop, and you want to try this one out. What you can do is, ahead of time, create some persistent volumes, giving them around 10 GB each. Or, you can turn persistence off, set it to false. Then it will not try to create any persistent volumes for Halyard here. I don't probably need to say that if you do not set the persistent to true, you basically, if the Halyard pod goes away, all the config changes that you made would be lost, right? Now, the good thing about using Helm and all that is that if you run it again, you will get it back. But if the Helm pod goes away and comes back up, any of the changes made, those are lost though. So that's the risk. So you run into, but if you want to just play around with it and see how it works, and you don't have a persistent volume, and you don't want to go ahead and create a persistent volume outside and make it available, you can just turn it off. The two other places where you need to turn persistence off in the default setup is if I go all the way down and let me search for Minio. Minio is where it's where Spinnaker uses to store all the pipeline information, right? And there is this settings over here, persistent enabled false. So you can turn it off. By default, it is enabled true. So you don't need to do it. But if you don't want to use persistence with Minio, you can basically uncomment these lines. Basically these two lines, if you uncomment and run, then Minio will not use the persistence in there. And the other place is Redis, which is right on top of this. I believe it is right here, Redis. Again, the same thing. If you don't want persistence or don't have it, you can just go ahead and turn it off, right? Over here. Now, while I was talking about this, I noticed the Helm chart came back. Now, let's look at the pods that got created. kubectl get pods -n Spinnaker. You can see the pods are coming up. Now, all of them are not ready yet. A few of them are still getting ready. So once they are ready, I will do it. Okay. Now, once it finished, you will see it gives you some information as to like, how you can access the Spinnaker uh, locally, basically. And that's how we'll do it. Basically, you expose the deck pod and queue forward or port forward to it. And then you port forward to the gate pod, deck and gate. And that's all you need to be able to access Spinnaker. And like they say that, if you want to customize it, nothing stopping you from connecting to Spinnaker, Halyard pod, and then run the HAL commands if you have been used to running the HAL commands. But my recommendation always is that if you go run HAL commands in there, you lose them really. If it goes away or you lose your persistent volume or anything like that. Best is to always come and edit this values.yaml and add them in this file, right? So they're persistent. And all the commands that you can run through HAL are idempotent. Basically, you run them multiple times. It doesn't have any side effects, basically, right? So you can manage this values.yaml in your Git, source control it, approval, so you exactly know what's getting deployed and manage that deployment. So my suggestion of a good practice is that don't go to Halyard and run the commands, but update the values.yaml to make the changes, right? Let's look at it if all the pods are ready or not. They are ready. And actually, we did pretty good. Less than 5 minutes. Or let me take the initial one when the Halyard came up. In about 6.5 minutes, we have our Spinnaker up and running, right? It probably took a little less because the images were downloaded, but you can probably give a minute, maybe maximum, to this for it to download the images. Otherwise, 7.5 to 8 minutes in a brand new cluster, you can have Spinnaker up and run. Let's access this, like they say. I'm going to just grab this thing. And after I've done this, I will basically show you how you can expose this as a service. So let's get the deck pod URL and let's port forward this thing. Let me run this in the background so that I can run multiple of these things over here. So I have a deck being port forwarded locally. And let me then do this with the gate pod. So now I know what my gate pod is. And let's port forward the gate pod to the local host. So I have both of these being port forwarded, right? Now let me go to the browser window and connect to localhost :9000. There you go. I have my Spinnaker up and running in less than 10 minutes that I have a Spinnaker up and running that I can start playing around with. It has installed the version 122.2, 122.2, and I can go ahead and create an application. I'll not do anything else, just let it create it. This is not about Spinnaker. I'm assuming you guys know Spinnaker already, or if not, there are a lot of other sessions going around where you could actually go ahead and learn other features of Spinnaker. And there are a couple of, blogs I've done earlier on these things, so, you guys can find it. But just to let you know that, hey, I have a Spinnaker up and running that I can actually use and run. So let me create a pipeline here. First pipeline. I will just make it a simple pipeline where I have a wait stage. Let's wait it for 5 seconds, traditional thing. Let's add one more stage, which is a manual judgment. Easy, doesn't require much things in there. Which is triggered after the wait stage. We'll ask for an input, proceed, whatever, just some input that I can give, right? Which I can use for downstream processing. And let's save the changes. So you have a pipeline ready. Over here, let's try to run this manually. Right? It triggered off. It will wait for 5 seconds over here. And then it's waiting for the manual judgment. Let's say proceed, and I say continue, and voila, the pipeline is done. So, all within 10 minutes, I have a Spinnaker up and running, created my first hello world type pipeline, and it's ready. Okay, let's get out of these things. I had the other one running. Let me kill that thing. So what you saw is how easily I was able to bring up a Spinnaker instance using Helm. All I needed was an available Kubernetes instance. Let's talk about the next thing, which a lot of people ask about, and I'm going to go here, is how do I make it available? I accessed it from my local laptop, right? Now I want to make it available to Tom. Everyone's virtual these days, right? Who's working from home. And I want to make this available to Tom. How do I do that? So what you can do is basically create services. So if you go to that same GitHub repo, there's a file called spinservices.yaml, right? What it does is that we basically create 2 node ports for the Spingate service. And then what we do is we create an ingress. Okay. Now, if you are not looking for authentication, you could always just create a load balancer service for Spindeck, and it would work, right? Like I'm here, if you guys know this, if I say gate/applications, it will return me my application. I did something wrong here. Oh, I did shut both of these down. So let's do the port forward to 9,000 all over again. Notice I just port forwarded to 9,000, right? I didn't do to both. So you can see that it just found and returned the applications that are available. I did not expose gate here. What it means is that the default Spinnaker installation through Helm charts, what it does, it routes gate through this path gate. And in Halyard, it's configured. If you know the overrides, it is configured to route gate request through /gate. So it works. So what it means is that if you don't care about authentication, you could just create a load balancer service to deck and you are done. But if you want to do authentication, specifically if you want to use Ldap, what you should do is you need to create an ingress, right? So you create an ingress where everything is routed to deck, except these 2 extra ones, /login, /auth, which are routed to Spingate services, which I've created as node port services, because these are not exposed externally. Externally, the access is through ingress. So let's run this file. And again, if you have any questions what I'm talking about, and any other comments, feel free to ask in the chat, and I'd be happy to answer them. So kubectl apply -f is the spinservices.yaml, and mine is in the namespace Spinnaker, so it's in Spinnaker. Looks like I had an ingress from an earlier time already in there. So it's going to reuse that ingress. So let's look at kubectl get ingress -n Spinnaker. There is an IP address, and I think everything should be ready to go. Let's see if we can hit this, or we need more time. So that's the IP address, and I go that IP address, enter. So the server is not yet ready yet. It's probably because, let's give it a few more minutes. It's probably not yet ready. So we'll come back and look at this. Let's talk about a few other things, and then we'll see if the ingress stabilized over here. We talked about what all enhancements or what we can do. So if you go look at that same Git repo, I have this thing called values_advanced.yaml that shows all the other enhancements that you can do, right? First thing which I'm going to talk about is not this section, but other sections here. If you have been making changes to your configurations, to your profile configs, like updating gate local or crowd driver local, you can basically make them available right here, right? Additional profile config maps, and you just put them in here. Now, you don't need to do this actually right in this file. If you know what it is, you can go ahead and create config maps and just say what that config map is, right? You could do that. But otherwise, you can just define them right over here. So this is where you define the profiles, and this is where you define the service settings. Now, this thing is quite confusing sometimes as to what stuff I put in profile configs and what I put it in service settings. The way I basically try to look at this is things that are needed by Halyard to bring up the service goes into additional service settings. Things that are used by the service at runtime goes into profile config maps, right? So gate local, if you want to make changes to gate local to say enable this, to enable basically this remote protocol header HTTP server port, mainly needed for cores, you just basically put this in. Or you want to enable logging at the cloud driver local. So you can basically set the logging level. So anything that you would set in a service, you can just set it over here and then do an Helm deploy. That would take care of it. Things that you do at a service level, which Halyard uses, like providing the image to be used, right? You can provide that here. Again, these are samples that you can use and edit it. One thing which I've seen I need quite often is this environment variable to define the Minio access keys. In some environments, these are not set by Halyard correctly, and so you have to inject those into the front 50 pod. So you could do that. So that's where you control the service settings and the profile settings. If you want to use custom BOM, how do you do that? You basically define it over here. Otherwise, you'd be going and creating these files in the file system in Halyard, and Halyard would pick it up, right? But you don't want to do that in this case. You want to maintain all of these in sort of source control and manage it. This is where you define it in the values.yaml, in the BOM sections, or if you have specific service-related configurations, you add them in the service configs here, okay? You can control the Halyard pod, how much memory CPU it needs. By default, it's not limited. But if you want to control the memory and CPU, you specify that limits over here. If you want to use the custom certs for the Halyard pod, that's what you defined here. Now, if you want to use this for other pods, you basically run Helm commands to do it, and that you would introduce in the up there, and I'll talk about it here. Out of the box, you can also provide Docker registry that your account should be using. Like if you have custom or private Docker registries, you can basically define them right over here. Like say, if you have a private GCR repo, you can here the username, which would be JSON key, and your service account, right? The JSON file that you download when you authenticate against a GCR repo, you add that over here. So you can actually configure Docker registries right over here. Kubernetes, two things. Here, when I installed it, I installed Spinnaker in the same Kubernetes from which I'm basically running it. But nothing stopping you from installing Spinnaker in another Kubernetes, right? Or let me put it differently. Have your Spinnaker deployed to a different Kubernetes. So you can define that right over here, right? What you provide is the kubeconfig file. It's either you basically load the kubeconfig file in a secret, and what secret it is. And in the kubeconfig file, you say what context to use, and what should be the deployment context in which Spinnaker would be deployed, and what's the context used by for deployment by Spinnaker. And you can have all these other settings that you typically do when you add a Kubernetes account in CloudDriver. You can define the namespaces or the omit namespaces, and even like, should it show only the Kubernetes managed systems or everything else? Again, that either namespaces or omit namespaces can be provided. You cannot provide both. So if you want namespaces, you should enable or uncomment these and comment this out. Or if you want to omit namespaces, just list out the ones that you want omitted. You can also define ingress. I used a file outside of it to do it. But if you have a host name and all that available already, what host name to use, you can use ingress right over here. Basically, your ingress should be, or your host name that you want to use for the ingress is set up, then you can use this to set it up. When you're deploying, if you want to deploy, like especially in Kubernetes, right? You want to have node selectors, you want to specify where the Spinnaker is deployed, or some tolerance you want to define, you can basically define them here, right? Again, these are Kubernetes definitions that you include over here. So like you can see, and we walked through the Redis. You can also use an external Redis. We did not give an external Redis, so it just installed a Redis by itself. Same thing with Minio. We asked it to use Minio over here. And you just don't need to use Minio. If you want to use S3, Google Cloud Storage, Azure Storage, all that you can define right over here to be used, right? So you can see this Helm chart provides you a lot of flexibility in setting up your production Spinnaker, okay? Let's see, I want to run through this and see if this one actually came back. There you go, right? So it's stabilized, it came back, and here we have our applications. This is my Spinnaker Summit 2020 application with my pipeline that I created, right? So this is available as, I wanted to go to the pipelines. Yeah, this is the Spinnaker Summit applications. Did I lose my pipeline? Maybe I did. Again, I'm not going to debug this here, just trying to show you how it works and all that. But this is how you basically bring up a Spinnaker. Now, let's show something that we can see quickly is talk about a few other things here. If you are in a restricted environment where you need to use service accounts to run Spinnaker and all that, you can define them right over here in the values.yaml file. If you have any questions on the values.yaml, what I can do, or hey, can I do this or can I do that? Feel free to ask me. What I did is really walk through the values.yaml. So yes, you could have always gone through the values.yaml, but sometimes trying to relate it to Spinnaker is what I think is missing in values.yaml. That's what I tried to do, provide that input to you. Now let's come to the final thing. What if I want to run some commands that is not available in values.yaml, right? I want to run a bunch of Halyard commands. You can do that actually. So it will actually run these Halyard commands before it will do a hal deploy apply. And all the Halyard commands that you want to run, you can just type it in here as part of additional scripts. Again, the syntax I'll not go through exactly. There's some nuances in how you set this up. You can always go look at values advanced and look at it. But main thing is that you can give this a command in this way: hal config, deploy, component sizing, deck, edit. So basically I'm saying that run 2 instances of deck, run 2 instances of run 50. That's what I'm saying here, right? And I can add whatever, any hal config commands right over here, and they would be applied, right? Let's run deployment with this one and see if we have multiple deck pods running or not. So if I go look at it, kubectl get pods -n Spinnaker. So we have, actually it probably ran that file. I have 2 decks already, so I probably ran that already. So let's do something else here. I'm going to remove this one out now and reduce this to, let's say, 3 instances of deck, right? And what do I do is helm list -n Spinnaker. And this is my Spinnaker running. So helm upgrade in the namespace Spinnaker, the release Spinnaker, SPI Spinnaker, from the repo Spinnaker, the chart Spinnaker, lots of Spinnaker here. And I want to use that advanced, right? Values advanced.yaml. And let me trigger this off. What I'm expecting to see is that once it finishes and comes back, I expect to see there are 3 deck pods running over here, right? That's the change that I made over here. Let's wait for that. While it is doing, let me talk a little bit about another thing that I hear people talk about quite a lot, is this, how do I configure Ldap, right? I know where my Ldap is. Again, like I talked about, you can always include this in this section right here, over here. So to enable Ldap, what you do is you configure security and you basically enable Ldap and then configure Ldap, right? So you need to give the user DN pattern you need to know and the URL to your Ldap, right? And there are a lot of other parameters, specifically like if your Ldap needs authentication to connect to it, like you can give the manager DN and all that also as parameters in there. You can look at the hal config security authn command to see how that works. And then you have to override it, the base URL for your UI. And what would be your deck hostname here? It would be the same ingress that we provided, right? It would be the same ingress IP address. Or if you have a hostname for there, you can use that. And once you do that, you do a hal deploy apply. Now, if you're doing it through this file here, you don't need to do the hal deploy apply, right? You just do these 3 commands right over here, and it would do it, actually enable authentication with your Halyard. It's running over there. So let me just add this over here. And if you have a little bit of a time, we will try to see this over here. This should be, see. And like I said, the URL would be this guy here. I do not need an extra level of HTTP, but that's about it. So let me save this thing here and see if we can enable authentication to my environment right from here. Now, I'm using an open Ldap that's running in the same namespace. It's not in default. It's in namespace Spinnaker. That's the DN pattern. Basically, a vanilla install of an open Ldap. That's what it would give it to you. So let me save that. And I noticed that this is finished over here, right? So let's look at the number of pods running over here. There you go. You can see there are 5 deck running, but you would notice that 2 of them are terminating, right? So I increased the number of deck pods running to 3. So let me just trigger off another one over here and and see if it gets enabled with open Ldap. So I've again saved that file, ran it. I don't have anything else to show. If there are any questions, I would be happy to take it. And this takes about how much time? 100 odd or maybe seconds, so which is about like 2 minutes, 2.5 minutes. I'll hang around for another 2.5 minutes and see we were able to enable authentication with our Spinnaker. And I'd be happy to answer any questions if you have any. While doing that, let me just summarize it. Again, if you have any questions, I'm available and reachable at on my email, nirmalya@opsumx.io. I'm also in the Spinnaker Slack channel at Nirmalya Sen. And if you have any questions, feel free to reach out. If you have any questions now, I'd be happy to answer it. And just to recap, we saw how you can, using Helm, within 10 minutes, bring up a Spinnaker instance and start playing around with it in a Kubernetes environment, and then all the additional configurations that you can do through Helm that Helm exposes, and anything that Helm doesn't expose, you can actually just run those Helm commands, and Helm will actually run those Halyard commands, and Helm will actually run those commands through. So let's see over here. This is still running. Sometimes while it's still running, this gets done. Let me try to reload and see if authentication is enabled or not yet. Not yet. We'll give it a minute or so here. I'm impatient here, so let me just Command T. This too small a window. Command. Actually, I think I lost my other window. I don't want to do that. Let me go back here. Let's let it finish here. Again, like I said, if you have any questions, I'd be happy to answer them. The one thing that can happen, if I did not give in the values correctly, it will wait for it and then it may time out, but I'm thinking it should be good. Authentication not enabled, it's standard. Hopefully it's not your demo blues. Let's see, while this is finishing, if there's anything else I'd like to point out here, that would be useful. Yeah, the other thing is that, you don't need to type it in here. You can create a config. This, what it would do is it would go ahead and create a config map in the Kubernetes and pass it on to Halyard, and Halyard would use that. So, you could actually just create that config map outside of this and give the config map name and use that, right? You could do that also. And have it use that config map. You don't need to actually type it in here. And that's a pattern used at a lot of places also, where you can actually just give it a config map where you have actually created the values ahead of time. Okay, let's see, it hasn't finished it yet. And I think it is more than the 2 minutes it took in the earlier case. Okay, definitely it timed out. It took more than it should have taken and something did not work. And gate did not restart, and we'll just look at quickly try to look at what went wrong. This is the task that runs it, that is still running. kubectl logs -f. Let's do the -p, -n, Spinnaker. Some parameter I provided probably was incorrect, and it's basically failing on that one. Let me not do an and. Oh, -p. So there was an entry. Oh, I probably made a mistake. I just said how. I did not give a command. Something went wrong over there. It tells me over there. I missed out the how config. That's why it failed in there. But, again, that probably brings up a very good point. What happens if it doesn't go wrong? So that's actually sometimes it's a good thing. And that's what I'm going to end today. Is if you look at the pods, there would be a pod that's called install using have. What it does is does all the prep work on your behalf. And so if something doesn't work correctly, like, if this is not completed, like you see over here, it's still running. That means something went wrong in the configuration. And if you look at the logs of this, it will tell you what went wrong. So that's what we did. We looked at the logs of this one, and it clearly tells me that, it expected a command here and it got security. So I did not tell it that how config security. So that's why this failed, right? So, although I was not planning to talk about how to debug, but because of the mistake I made over here, not giving the config, it actually gave me an error as to what went wrong. With that, I see no questions. I'd like to thank you for your time. Thank you for listening to me. If you have any suggestions how I can improve this, or if you have any questions, feel free to reach out to me at nirmalya@opsmx.io, or I'm on the Spinnaker Slack channel at Nirmalya Sen.
right.